but the whole thing has to do with the paths. We also have a bit of conflict between the Windows subsystem and the PowerShell. So my advice is just get a mixed system. But some of us have had some issues, some of which have been resolved simply by either clearing all the directories or the containers and then restarting them. That seemed to work. But just so that we can move on, I'll try to explain a little bit of what's happening in the background. Okay, so what we've done is we've mapped. We created a directory in our host system. Remember that the container runs in a special system, and these two are isolated from each other. And therefore, by using the -v, we are binding two volumes. So we are telling it, stuff that is contained or being created somewhere within the container can be mapped locally, so that then we can either manipulate those. And that also happens if you want to run files within your file system and get some output out of it. Okay. And just to illustrate that, what really we are doing, I'm going to try and use a previous command that we did earlier on in the day, which has to do with Docker execute. Okay, so I'm just going to try and do this.
By the way, I was able to run it and get the log file now. The codes are so when I went into the folder, it automatically gets log on right axis. So you have to change after creating the Galaxy. I don't know why, after creating the Galaxy log file, you change the permission of the folder to right.
Oh, that's an important one, isn't it? So, for example, I think if you're within your own directory and you are sort of a root, Galaxy is coming with different permissions, so it looks like it's a new user, it's a different user altogether, and therefore they can't write, because remember you're writing to your own host system, so you can't write. That's a really good one.
So I also know
so you just change the permissions.
I changed my all these permissions and now
Awesome. Yeah, that's a really nice pattern. Because the container will be running with a different user, and they don't have access to you. So that could be what happened. Just which command is changing the is it usually change owner, change mode? Yeah. Like,
I just use
change mode
I just went to the file itself, so
yeah.
and you click on the on the what is the envelope menu for the files.
Yeah. Okay. Change mode so that you allow write permissions. Yeah. Yeah.
Oh, I didn't use each one. I just
she might have the same thing. Ask her she actually just change the permissions. You can put say one list and you see, yeah, these are the permissions. This is a directory. They try to execute for the contact. They try to execute, but then they try for any other person. There's no right. So if you do,
they'll on your own. Is this not your own? So that's fine. That should be on the space game. Should be right?
Yes,
Maybe it might be something. Isn't it CH?
uh, the volume binding may not be very straightforward as to where they are located. Okay, so what we're going to do is that we're going to issue a command here, which is docker execute, isn't it? So we can execute a command on a container. Okay, so docker execute needs to know the container ID. Okay, so for me to know what my container ID is, I may just need to first run the docker ps just so that I know my ID, and this is it. So the container ID is this number here. Okay, so I'll simply copy it, and then I'll run docker execute. Image, and then the command that I want to run on the container is ls minus l. Yeah, exec, no, I typed the whole execute. So if I do this, and I go to the logs, you can see that the logs are actually within the container. Are we together? Okay. What I've done here is to look at the file system in the container. And essentially what we're doing is that this file exists in the container, home galaxy logs. Okay? So if I execute ls on the container, I can browse the file system in the container. Okay, and what we're really doing is mapping that directory into our home directory. Okay? So it'll become a bit clearer when we create our own Docker file. And just looking at time, we might not be able to do that today, but I'll find time tomorrow, one of the sessions once Juma finishes, for us to go through that bit of it. But I can walk us through creating Docker files. Okay, but this was just to show us that we are able to map this directory in the container back to our home directory. So when you're working with Docker, you're able to copy files from your file system onto a folder in the container. Okay, so if you're creating a Docker image, we also specify that, and also you can copy things off to the container. And it also means that when I mark this and I had an executable script or a tool running on the container, I'm able to execute. And as long as I've mapped the destination where that output goes to a local folder, I'm able to write to my home directory. Okay? Yeah. So we will have a bit of practice with that. And I know for those of us that this is all very new, it can be a little bit difficult, but with a lot of practice we can. And definitely, for those of us on Windows, the whole mapping and the pad, the backslash and forward slash always creates issues. And also realize that there are problems with when you're running Docker off PowerShell and when you're running it off the subsystem. Okay, so
which is why you don't run it on PowerShell. You run it on, but
even with the Windows subsystem, we've had issues.
But Docker for Windows, if you actually look under the hood, the new Docker desktop for Windows is actually using subsystem.
Oh, is it?
So in fact, if you run Docker containers, so if you've got WSL, Windows Subsystem for Linux, you're running Ubuntu inside of Windows, okay, using, I think, virtual machine, right? I think it's a virtual machine. But Docker is used, so when I shut down, the reason I know this is because sometimes my Windows Subsystem crashes. So I open the PowerShell in admin mode and I say WSL minus shutdown, okay? fact, we should put a few tips for dealing with WSL problem somewhere, because
We should, because
it
it
does freeze up sometimes. So then you go, well, I've got to shut down, to shut down the subsystem. And then your if you've got Docker desktop running at the same time, in Windows, I mean, it will give you a message when you're shutting down WSL. Hey, you've shut down my Docker system. So it's actually using the same system, the new one. Not in the past, Docker for Windows was doing a different thing. But the newest one, it's actually using the same WSL stuff. And then your Docker containers, but the only difference is because it's running its own subsystem. So, George, if you're running on Ubuntu and you run a command inside Docker, and it's using a lot of CPU, you'll actually see that in the list of processors on your Ubuntu processors. This command is using a lot of CPU, and that command is something running inside Docker. But on WSL, you won't see that guy because it's in a different box, but they're sharing the same, so you have less of the problems of bunnies, slashes, and like that. But John will show us tomorrow how to ignore absolutely everything that you're doing right now, because your workflow manager will manage it for you with Nextflow, right? With Nextflow, all of the paths. But to understand what's happening, when Nextflow runs and it's using Docker, it's using what you're using, right? What you're talking about.
Yes.
But it hides it all for you.
This time you shouldn't have said that.
But the thing is, look, when it breaks, you must know what has broken.
Yeah.
Right. Like when it breaks, you must understand what is this thing. How did it work? Unless you're Mpanga, if Mpanga wants to become the boss, then he will delegate his new underling to fix it. Yeah. But yeah.
Yes.
I just feel like something I'm waiting for tomorrow's.
No, but you must understand the technology. And no, I won't say must, because they never must, but it's very useful too. Anyway, back to George.
Thank you, Peter. So I just want to sort of summarize what we've gone through in the morning session and the afternoon. It looks so much, but literally this is the steps that, in summary really. So we installed Docker, we learned how to troubleshoot it, we know how to pull images from the repository, that's the registry, and we also know how to list images. We know the difference between images and containers, so you can spin off multiple containers from a single image. We know how to look for running containers using the docker ps command, and how to stop them using a docker stop command. And we also know that we can execute arbitrary commands from our container using the docker exec or execute. So exec command will take the container ID. We know how to obtain the container ID using docker ps, right? And then we can issue the command. This command will run from the container. We just did an example where we looked through the Galaxy container file system, okay? And we're trying to look where the logs are, okay? And we'll be able to do that. And docker stop will literally stop your container, okay? And docker rm will remove that container. So I'm gonna stop there. And my next exercise was actually to try and create a Docker file, just so that we can do it. I did run into some handwrits because I wanted us to go through a tutorial, and something is broken, but we will go through this nonetheless. So creating, these are not my best slides really, but I'll polish them because I still want us to learn how to create a Docker file. It's actually really trivial and straightforward. So a Docker file is simply a list of commands, more or less like bash commands, and they progressively build an image in what we call layers. Okay, and there are some tips on how to do it, because the more layers you have on your Docker file, the bigger the image can be. Okay, and often you really want to have lightweight images. So if you're not careful, and I'll show you, then you can end up with these really huge Docker images that are gonna take a lot of time to compile and to download. So the list of commands are just as I listed in capital letters there. So from will list the image that you want to inherit from. Okay, so there are images out there. So for example, I may want to create a Docker file for a specific utility, let's say primer trimming. Okay, I'm going to inherit from an Ubuntu machine or an Alpine machine or CentOS, or one of those. So that will be the primary machine. So I would say from, and then I'll state that image, and run literally executes the commands, shell command. So for example, if I'm creating something, I may want to install the tool. So I'll say run wget, give the URL where the tool is, then I can do another run, but remember what I just said, that you're creating multiple layers. Instead of doing that, I'll run that as a single command using the double ampersand sign and continue. Okay, so that you just have one single layer. And then I may need to compile it. So if I'm on Ubuntu, I need the build essential list of commands. So I may do double ampersand apt install or apt get build essential. And once I do that, I may also want to, once the tool is compiled, I don't need the build tool, so I can remove all of them so that my image is lighter. Now we'll see an example. Copy is going to copy data from the host to the image. Okay, so for example, you see a tutorial that I've written. You may want to create a script, and I want to copy that script. It will be in my host directory or somewhere, and I copy it to the image. Okay, and then I need to set an entry point, which is the command that will be executed when the container runs. Okay, the first command, and the working directory like CD and others are working directories for the build. Okay, so I often will create a working directory, and then I can map that working directory and bind it to my working directory on my host or my file system. Okay, so that whatever is executed there, is bound to my machine. And this is how it looks like from Ubuntu. Okay, run apt-get update. I want to update that box, and double ampersand apt-get install curl make build essentials and leave SSL. So that is going to create. If you execute that, I don't have an entry point yet for that, but that's how those images would look like. Okay, so I'm inheriting from Ubuntu as my base OS, and I'm simply updating it and running curl, installing curl. And to build it, you simply use the build command, and then you give it a target. That will be the name of your image. Okay, so for example, Docker build -t image name, and this thing here, it says here. So my Docker file is in the current directory. Okay, and the Docker file has to be named Docker file, like capital D, D-O-C-K-E, F-I-L-E. Okay, and we see how that can go. So I have an exercise here, which is localizing some tools by creating a Docker image for some tools. I know that I have time to do this. For some reason, this refused to compile on my Docker. So I think we'll get to do this hopefully tomorrow. But it isn't time. So minimize the number of run in your Docker file. I will show you an example of a Docker file that I had created earlier. use no install recommends, and remove tables or the archives. Once you download and install the tools you want in your container, you want to remove the tables, the primary data sets that you use, and then clean package list that are downloaded, so that we can have a lightweight image.
And if you're doing a Docker image for a bioinformatics tool, contribute your bioinformatics tool to bioconda, and they will automatically build a Docker image for you.
Oh.
So if you make, like, let's say you've got, like Tracy has a tool that she's working on called Cosmo. So once that thing's ready, and that thing is added to bioconda, then there's a project called biocontainers that will automatically get a Dockerized version of the tool and singularity images as well. I'm sure you haven't got the singularity.
So
the other, so then, and they optimize. So what they do is they actually use they use the I forget the particular command, but it's one of the newer ones you can do in Docker files, where you build up everything, like you compile the software and things like that, and then you can copy just what you need to a file, like then and throw away the kind of build stuff. But so that means that you don't need to build your own Docker image if you make a bioconda recipe.
So we did talk about biocontainers, and the last time I used it to work, then this morning it's not working.
Biocontainers?
Biocontainers, yes.
Okay, well, I don't know why you broke it. So,
okay.
The biocontainers is there, and it's we must just see biocontainers.io, I think is the website. And I do think I mentioned there's another group, but besides biocontainers project, there's a group called Staff B.
Yeah.
That builds Docker containers, state public health bioinformatics. But anyway, we'll make sure that we just must make sure that all the resource links are all there.
Yeah. So this is just a summary of the key commands if you want to build Docker containers. It's not that complicated. It's we all know these commands in a way, and if you're working with Unix Linux, you already have a muscle memory for these commands. From work directory, run, copy, add, entry point, CMD, expose, and the label. Okay. And once you've done that, this is what Peter is telling us, is that you can build and upload your image to Docker Hub. Okay, it's for others to make use of. Or push the locally created image to Docker Hub. This is where you need your login, and then you push your tool off to Docker. You can save images on your local machine as a file. Simply Docker save my image as a table, and I can load that using Docker load command. Okay. So I think I'm gonna stop there. But I did want to show us something that I was working on that has previously worked. But I'll walk through it, and tomorrow we'll have an opportunity to actually try. I ran into some headwinds. That's why I don't want to execute it. Previously, because I made it to inherit from biocontainers, and biocontainers was not working, so I changed it to try and build it off from Ubuntu. And I tried to execute it here. I didn't work. So, but anyway, so this is an exercise that aims to do something that a lot of bioinformaticians already know how to do. Probably will be requesting to do it, and essentially, it's a primary mover tool using CatAdapt. Okay, so what we want to do is write a very simple script called CatAdapt, remove primers. It does just one thing. It assumes that CatAdapt exists in your sort of shell environment. You have access to the tool, and it tries to remove this primer specifically. That's not a very good thing because it's absolute. Ideally, I would want to do -a file and give it a file name. that I can always change. And then my sequences without primers and sequences the faster. Okay. So it will take my sequences that have the primer and then it will output sequences without primers. So quite basic thing. So what we're going to do is that we're going to containerize this tool because we are advanced informaticians. We know how to do this stuff now. Okay, so we're going to build an image from Ubuntu. So I do from Ubuntu latest. Okay, so it's going to take the latest image of Ubuntu. This might not be a great thing because that image I think is relatively large. So yes. Okay, sorry. Is that better? Okay, good. We're building from there. We're running this command here, which is going to update the image, get us the tools that we need. That's the build essential, wget, and zlib, and then apt-get install the tool that we want, which is cut-adapt. Okay. And you can note here I'm running this as a single run command and using this ampersand to sort of chain them together. So do that and then do that, and I'm using this backslash to simply continue. So rather than if I wrote this all as a single command, it would just go on and on. So this is just for convenience, really. But the Bash does understand what I mean. And then it assumes that cut-adapt exists within the apt-get. So if it doesn't, I would need to do like wget and then download the tarball and compile it. And I can do all that and then get rid of things, tarballs and stuff, okay? So here we are cleaning unnecessary packages, assuming that this has been installed and that has worked. I no longer need this, okay? Because if I keep them in the image as files, this image is going to be large and unnecessary. So I want to clean that up. And then I'm going to copy my my remove primers.sh file from my current directory using the copy command, and I'll be copied somewhere within the container. So in this case, it's getting copied in user local bin. Okay, I could also just copy it in slash root. Okay, and then I want to make sure that it's an executable script. So I do run change mode, give the execute permission to this file, and then I set a working directory, which I'm just going to call /data. And this is important because then I mount this to another file within my working directory, okay, or within the host file name. And I'm going to set the entry point. So this is the command that gets loaded or run once I run this container. Okay, so I set that working entry point, and that's it. So if you look, the steps are relatively straightforward. We're starting off from an existing directory, and we're starting off from an image that is already in existence, and in a sense we're doing the activities that we did earlier yesterday, okay? But we're only doing it once, okay? We're only doing it once, okay? And if we do that, then we have a Docker container that just does one job, okay? Which is to remove primers, okay? So then we can sort of make use of this container simply by running it and binding our current directory. So this is another way, you know, we were using that fancy icons for PWD. You can just do this. I think, and Peter showed us this yesterday. Yeah. So there are PWD within. No, yesterday, the day before yesterday. Okay. And that will still give you the path. So here we're mounting our volume, and we are mapping to data, and then we're executing the tool. Okay. So assuming that we have our data, that command is going to do the primary method, and that's all we need to do. Okay. You can verify the output, and the next one was for making sum tools, and this one where you like download and do the install and so on and so forth. Okay, so we'll have an opportunity to do that tomorrow, and I'll share that, and then we can troubleshoot if we run into some headwinds.
Yeah. Just okay, it's not really a question, but I just want to find out if using something like Docker for or containerizes a process like this isn't a bit of an overkill, because in essence we are looking for ways to be efficient, but we don't want to overdo it in certain aspects of it. For example, if they say you can easily write a bash script for this and then run it, wouldn't it cut the stress you have to go through to make it a containerized Docker file before we run and so on? I think what I mean in essence is that isn't there some kind of threshold where, okay, if your task isn't as dense or packed as this level, well, you don't need to really go into Docker or something like that. I think that's what I mean.
So again, I did mention that a lot of what we're doing will be very much dependent on the task at hand, the resources you have, and the complexity of that task. Okay, and the systems that you're using. So what I've just shown you, it may look like an overkill because maybe it's too much information overload right now. But once you get used to these processes, you clearly see the advantages of it. And the other way is, before that, we simply pull stuff from the registry. And what I've just shown you is how to create stuff. Again, you'll always find that, let's say you're a head bioinformatician in an institute, and you're working across multiple groups, right? And you have the same thing. So rather than reinventing the wheel every time, spending too much, I'll just Dockerize stuff, and I'll tell them, send you an arrow, and let them pull that image, and if they run into issues, let them come to me. Okay, so I've saved time. I don't need to work on it, and they can run away with it if they want. Okay.
But just also on that, so Tracy was raising the issue. So I'm the co-chair of PHAGE's infrastructure working group. Okay. So PHAGE, for those who don't know it, is the Public Health Alliance for Genomic Epidemiology, and it's a volunteer-driven collaboration on best practices. The infrastructure working group is on what is your best practices for infrastructure, right? And Tracy had this idea. She's also works for PHAGE, and she comes to all of our working group meetings and tries to coordinate work and things like that. Let's make a decision tree. When are you going to do which way of doing things? So I was showing you guys on Monday morning doing analysis, not even using a script, just a whole lot of things in one command. So I was just, I don't know, I'll just say, I'll call it back. Like there, moving to saving things in a script is one level further, right? Because that long command lines, cut, sort, blah, 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 if you don't write it down, you could forget it, But, so are you doing a new operating procedure for your lab? Or are you doing the analysis to make the report customized once off? So what are you doing? Okay. or are you looking after your infrastructure? So we used to have computers in our data center over there that all had names. Baboon server, they would have school server, normally named after the project, okay? And we had this one lambada, we used to name things after musical terms, okay? And I could not like let that computer, if the power supply crashed, I had to replace it because nobody could remember how the software had been set up on the computer. Okay, so we had to keep that computer alive for years and years and years because somebody was running some servers there that must keep alive. Okay, and if the hard drive died, it was a problem. But now that we've got Docker, I mean, it's a bit of a joke, but I've got a piece of software which I wrote in 1998. That a few years ago I decided, let me preserve this for the ages. So I made a Docker container of it, you know. So now I don't need that setup, you know. So then our major infrastructure there. So we were running, George I think was mentioning with CentOS and the problems we're having with CentOS and what's going on and things like that. So the latest version of our storage system is running using Docker containers. The operating system it's running on is CentOS. It's actually quite an older version of things. But inside the Docker container, it's running the latest software without us having to update the operating system. Because Docker hides all of the details, you know, and it depends on what you're doing. So if you're doing that like one line thing, obviously you don't need to containerize. But you also don't want to get into the situation that I was in, where I have to keep this computer. And the other thing is, I've forgotten how I configured this computer. How did I install this thing, you know? And all of those kind of things. So Docker means I don't need to remember how did I install this thing because the Docker file that's there on your screen, that's how you install it. There, it's documented. You know, that said, you must have that Docker file because sometimes I get Docker containers. For instance, anybody here using Midnight Kits from Oxford Nanopore for their sequencing? SARS-CoV-2 sequencing Midnight Kit?
Yes.
Yeah. So have you used the Epi2? Has anybody here used the Epi2Me workflow that goes with the Midnight Kit?
I tried it.
Okay, but it's called withArtic. Okay. If you don't use withArtic, anybody here who's using Midnight Kits getting low coverage on their sequences, having coverage problems. You see, there's a problem. The Midnight Kit from Oxford Nanopore is a tagmentation-based, it uses rapid tagmentation-based library prep, okay? The original withArtic from the people up in Birmingham assumes that each read spans an entire amplifier.
Yeah.
But with rapid, it doesn't, it's fragmented.
Yeah.
So Nanopore, they've modified that Arctic software to deal with their kits, and they've wrapped it in withArtic. And the only place where that software exists is inside their Docker containers. So I had to go dig inside the Docker container and compare that to the original Birmingham code to understand the difference that they've done. So if you don't have that Docker file, which is the recipe for how you made it, a Docker container can also be a black box. So you must keep your Docker files preferably on GitHub or somewhere like that, you know. But yeah, we can talk over coffee about Midnight Kits and withArtic because there are problems that are not widely publicized with using that thing.
Yeah. And I think what Peter just
because I mean you're using Arctic with Nanopore, right?
yes, but
because you use
never
the
got to
original
use
low cost.
low cost.
Yeah, low cost is a ligation based
Yes.
protocol,
Yes.
not rapid.
Yeah.
Yeah.
We never went the midnight. Essentially, what Peter really went through is this list. Yeah. And as you're asking, it does depend on what scale, and obviously there may be limited utility. We're just doing one small thing, but often been in bioinformatics long enough to sort of really appreciate these tools and not reinvent things. So at this point, if I just do something once, right? I really want to do things once. I don't want to do things multiple times. You know, I don't know whether it's that. Remember, there's that thing about. It's a really nice cartoon from Chris Munger about two developers literally playing in the room, and then they asked, what's going on? What are you doing? And they say that we are compiling. I'll put it up for you. Okay. I love that.
Compiling
Because,
a big software can take hours.
yeah. Yes. It's a really nice cartoon from Chris Munger. There's this really nice cartoon here. I don't know whether it's visible. The number one programmer's excuse for legitimately slacking off is my code is compiling. Okay. You can say what's there, get back to work, I'm compiling. Literally the guys are playing.
My analysis is running.
Yeah, my analysis is running. So if I can do Docker containers and run it, I can game it. Yeah. Run around. And if you ask me, I'll tell you I'm working. Yeah. So I don't want to be,
Okay.
not all the time. I don't want to be at the computer all the time. I want to run away, do other things. So that's classic.
But we use Python, we don't code Python.
Yes.
Yeah. So as long as you tell management you're compiling, they're like, carry on. You're doing something important. Okay. Yeah. So by informatics is the analysis is running. That's for results. But the point is, try and cut down inefficiencies, and Docker can help you with that. Right, I think it's just about time for tea, and I think we can leave early. I'm a bit exhausted with the talking, but we can get around this tomorrow if Juma takes us to the next flow, which again will show you how to do this sort of thing and create pipelines to run analysis and run off Docker containers or sometimes Coda containers. And you don't need sometimes to really think about it. So you can set up a container, Nextflow, it will pull out all the necessary things from where they are needed and create an entire workflow using a domain-specific language called Nextflow. Another one is SnakeMake, that is more or less Python-based. But Nextflow is slightly different, a little bit of a steeper learning curve, but a lot more productive, in my opinion, than you can do with SnakeMake. But sometimes it's like a choice between the two. Are you SnakeMake? Are you Nextflow?
But
Are you Emacs? Are you Vim? Which church do you belong to?
But John's thing as well, even if you don't ever write any Nextflow ever in your life, I wanted John's input because next week we're going to use a pipeline which is written in Nextflow.
Awesome.
And I want you to be able to read that pipeline and understand what it's doing. That it's not a black box, The main thing is to, even, like for me, je ne parle pas bon français, but I can understand it, I can listen to it, I can read it. And this is, to me, good, And if I could do that with Swahili and Arabic and things, that would be even better. But yeah. Well, I learned that when I get to Kilifi.
Yes. The coast in particular is the home of Swahili, so we are very proud of
I know songs in
Swahili.
Swahili.
Are there songs in Swahili? Some of the most beautiful poetry is in Swahili. I'll show you.
What's it, guys? That's it. See, Ali, want to leave? Say something like that?
Alright, so I'll stop there.
I think we can give George a hand for 2 days. And if you have any thoughts about today's training, good things on the green, things that you think we can improve on the pink one, and you can just stick it in front as you head out to tea. We really are taking your feedback seriously, so please take a minute just to think about it. If you have any useful suggestions, please do stick them on the front section of the paper.
And things that didn't work.
Yeah. That should be improved. Yeah.